Hey everyone, welcome to another Open Cluster Management Community meeting. Today is November 25th, 2022, and today we're really excited to have Chungling, who's going to present the one multiple OCM instances in a single Kubernetes cluster. He's going to demo and talk about the benefits of doing that. Chungling, without further delay, please go ahead. Thank you. Chungling, um, can you hear us? Can you guys hear me, or am I
I
we
can
can
hear you.
okay, I think Chunglin flows. Okay.
Okay, yeah, seems yeah, my network is unstable, so can you hear me now?
Yep, we can hear you now. But we can
Okay,
see your screen. Please go ahead and share. Thank you.
okay,
Yep, we can see it now.
okay, cool. Okay, thanks, Mike. So yeah, today I'm going to talk about this issue to run the multiple OCM instance in a single Kubernetes cluster. So yeah, we propose to have a standalone control plane. The standalone control plane can be running in a namespace. That means that we can run multiple standalone control plane in different namespace in a single Kubernetes cluster. And we need to have the endpoint for the standalone control plane exposed so that we can use this endpoint to allow the managed cluster to be joined to this control plane. And also, yeah, we care about the how short can the control plane started. So I think that we have two major use cases for it. The first one is for the scalability issue, that due to the Kubernetes limitations. So for the single standalone control plane, you have the limitation to manage the number of the managed cluster. So when we can have a multiple control plane, we can manage more and more managed cluster. That is the one case. Another case is that when the customer want to have the multi-tenant, so the customer can start one single standalone control plane from one organization. So that means is each organization can have one control plane that can help on the multi-tenant use cases. So I'm going to have this chart to show it that here the chart is we have namespace 1, namespace 2, namespace 3. Both the three among the three namespace, we have a standalone control plane running in a pod and start in this namespace. And beside the standalone control plane, we can have some add-on installed and connect to the standalone control plane that requires the add-on to be running in hosted mode. That means the add-on is running in its namespace, but it connected to the standalone control plane in its namespace. And also we have a syncer. A syncer is a new concept that it is a more related with the management because when the user install the multiple standalone control plane in different namespace, how to manage this control plane, or the customer may have some cases to propagate some global policy to each standalone control plane. So that is why we introduce another one is called global hub. So the syncer functionality is to sync the resources from global hub to the each standalone control plane, and also can report the status from the standalone control plane to the global hub. And the global hub is actually a lightweight version, so it can user can access the global hub, can create some OCM resources, for example, the policy, or the global hub also can check the status about the managed cluster. And yeah, each standalone control plane can have a classlet or can have the managed cluster to be managed. If no questions, I will going to do a demo. Here is we have put a prototype in the OCM, the name, the branch name standalone dash control plane. And when you go into the hack demo, here have a simple demo here. It is very simple. You just need to connect to the OpenShift cluster. Yeah, right now we did not test the Kubernetes cluster, but it should be easy. The only thing is that right now we use the root to expose the endpoint. So if you switch to use the Kubernetes, so we may use the service or notepad to expose the standalone control plane endpoint. So and then you need to install the latest class admin and install latest customize, and then execute this command. The two means is I want to install 2 control plane instance in 2 namespace. Okay. Okay, so so the first I want to deploy standalone control plane and also have some add-on in the namespace OCM-controlplane-1. And yeah, here we will start to deploy it, and we generate some certificate for the control plane API server. It is for the serving certificate. And after, you can see that the control plane is started very quickly. Here we check the control plane is started successfully or not. Once the control plane is started successfully, and we will deploy the add-on upon the control plane. So here we can see that the control plane is started, and we deployed some simple add-on. It includes the managed service account work manager and the policy add-on. The control plane is ready, and then I will create a CAN cluster as a managed cluster to be joined to this control plane. Okay, once the CAN cluster is created, and here we will use the cluster admin to join this managed cluster to the control plane. So yeah, we will get join request, and we will see that the classlet is installed in the CAN cluster, and then wait several seconds, and then execute the accept the join request. Okay, here we can see that the CSR is approved. The CSR is approved, and here we can see that the managed cluster is joined, and also we will list the managed cluster add-on. So here we can see that we have the work manager, we have managed service account, and also have the policy framework and configure policy controller. And we will start to deploy another one in the OC ControlPlane, OC-ControlPlane-2 namespace. Okay, the control plane in namespace 2 is created, and the add-on is also installed successfully. And I will create another CAN cluster. This CAN cluster will join to this new created control plane in the OC-ControlPlane-2 namespace. Okay, yeah, we repeat the same one. Use the class admin to join this managed cluster to the control plane. And yeah, once the classlet and the CID, the required CID are deployed successfully, and then it will send the CSR request to the control plane, and then we will accept this control plane, accept this managed cluster to join to the control plane. Okay. So yeah, we can see that this managed cluster OC-ControlPlane-2 MC1 is joined to this new control plane, and we all see that the add-on managed cluster add-on is available for this new control plane, and then we will deploy the global hub. The global hub is in a default namespace, and after it quickly, so the global hub is deployed, and then we will deploy the sinker in each namespace. Yeah, the sinker is deployed in namespace, OC ControlPlane namespace 1, OC ControlPlane-2 namespace. Everything is deployed, and then yeah, the deploy is successfully. So we can use this one to check it. Okay, so we can see that yeah, the temp could configure it to access the global hub. So in the global hub, we can see that we have the two managed cluster. Actually, the first one is connected to the control plane 1. The second one is connected to the control plane 2. And then we did a new CRD for the hub control plane. So you will see that it is just to show some information for the for each control plane. For example, when you check the OC ControlPlane-1, you can get the endpoint to access this control plane, and also have some status reported. So here the add-on, you know that it is the same as the real cluster. The add-on available have the work manager, manage service account policy add-on, and also we'll list the available managed cluster, because I just created a single managed cluster. So here that's available and this one. So the status can be available or no, and yeah, another one I can't remember. So and then the user can use this endpoint and provide the token to access this control plane. Okay, so I think that's all for this demo. So any question, any comments? Hi, Mike.
Thank you.
I think,
that was,
yeah.
that was a really great demo. Thank you so much. Can you talk a little bit more about the benefits of having this setup? I know you talked about the scalability where there might be uh, was it the etcd limit regarding the amount of resources? That's why we have to do this. Can you talk a little bit more about the advantages of doing this setup? Thank you.
Okay. Yeah. Okay. So, the setup we have the. Let me find. Oh, okay. I can just. Okay, so for the setup, we have the control plane, and we have some add-on, and also we have a syncer to do it. In the OCM control plane, actually, we start the Kubernetes API server, and also we have the embedded etcd to be started here. But yeah, we are still working to share the etcd by the multiple control plane, because I think for these cases we are care about the footprint for the control plane in a namespace. So if you can see the matrix, you will see that for the control plane, it spans more than 400 megabytes. So we are working to reduce the memory consumption. We did some investigation for the etcd. It spent more than 40 megabytes memory. When we remove it to have a shared etcd, we can have some benefits. And also we work on how to reduce some memory for the Kubernetes API server, and also for the registration and placement. I did not mention it before, but for the OCM control plane, we have embedded the registration and the placement controller in this one. And the registration and the placement also spend more than 100 megabit memory. So we are still working on that. We want to reduce the memory consumption so that it can easy for the customer to use it, to have a very lightweight version to do it.
Thank you. Are there any other comments? Qjang, do you have any comments or question for Chunglin?
No, I think that it looks good. I'm still thinking that so because we have a cluster manager API, it just occurred to me that there are some similarity between the cluster manager API and hub control plane API. Maybe we could discuss about later on whether the we can reuse the cluster manager API or enhance it, so that API can also support like the standalone mode of installation. But it's just a new just occurred to me just now, so I don't have a very clear answer for that yet.
Okay, thank you. So, yeah, so do you agree to have a rapport in the OCM organization to have the multi-cluster DAS control plane, maybe this name, add a new repo in this organization so that we can put some code here. And I think we still need to have an operator to for the installation, because you know that right now we just use shell script to generate the certificate, and also yeah, we did not consider the cert rotation, etc. So when we have an operator, so the operator can take over such things.
Yeah, I think the name is okay.
Okay, thank you. So once we have this report, and we can add some testing or add have some simple example to allow the community user to have a try. Maybe also we need to have a solution to support non-OCP cluster. Okay, thank you.
That sounds
Yeah.
great. Thank you, Chunlin.
I think so. I think we probably should provide some way that it doesn't really need the OCP. For example, I think we could have several different mode, like using a Docker or Podman to start it, or a way to start it using a kind, something like that. So it could be used in, I mean, different mode.
Yeah, yes, we can start the control plane in a container and start multiple, and then start the can cluster to join to the multiple standalone control plane instance. Yeah, we may can add some testing to ensure that the case can be used to verify our code.
Yeah, I really want to show this to the SIG multi-cluster community as well. I feel like this is something that they'll be interested in. Hopefully, Chunli, I know the meeting is a bit late, but maybe hopefully you can join me. But let's see what
Okay.
happens, because I think like you said, we probably needs to be non-OpenShift specific first. Thank you.
Yes, thank you, Mike. So yeah, I think that we may first create a report and have some non-Kubernetes sample, and then we can present it in the multi-sig meetings.
Sounds great. Thank you, Chunlin.
Yeah, thank you, Mike.
Any other question, comment for Chunlin? Qicheng, I think this is it for this week. Any other topics you want to discuss?
No, the only thing that so for the oh yeah, one thing is for the placement add-on score that we discussed before, like there's an issue about the score is not updated when it's changed immediately. So I put a peer in the placement, try to fix it. So please take a look, and And if we, I think that is also some requirement from the Argo City workflow. I think if we have it, maybe they can use latest image to take a try.
Okay. I think the Hypershift and the service delivery team also need this as well. So, going back to the placement score. So, is it still using the valid until based on what Queen Hao and you discussed how we leverage the valid is it valid until field to requeue the placement?
No, it's I changed it to just a watch, so it's not depends on valid until. It's more like when it changes, we will just do the reschedule immediately. I think there might be some problem with that if there are many clusters, but we can verify it later if we need to do some rate limiting when there are many clusters and the score change very frequent. But at least in the current fix, we just watch the score, and when the score changes, the schedule will be done again.
And this is by default, the default behavior, not hitting behind a flag or anything, right?
No, it's a default behavior.
Thank you, QJ. I think this is exactly what they're looking for. but yeah, that sort of leaves the power into the whoever's updating the add-on score. Like if the agent is updating the add-on score quite frequently, then it'll get reconciled quite a bit. But I thank you so much for this this PR. I'll let the Argo workflow folks know. Thank you.
Okay, thank you.
Okay, that's it. Thank you everyone for joining today's meeting. If there's nothing else, have a nice day, everyone. Take care.
Thank you.
Thank you.